Let's look at a subset of mathematics, which is not really the pure side as such, but it's the financial mathematics, the everyday dealing with loans, financial investments, things like that. So insurance policies, or rather, let's say retirement policies, things like that. We're going to look at these now, and before we get into it at this level, let's just do a very, very quick recap. Okay, this is our financial maths, and let's just do a quick recap of earlier work. On the recap side, we said we had two kinds of interest: simple interest and compound. And what did we say? Basically, simple interest took us to there, and we had a formula for that one, which was A is equal to P times 1 plus I n. We're not going to be using simple interest in the stuff we're going to be doing currently, but just to know it's there in case somebody does ask a question about it. And A and P, A is called the amount, and P is the principal. That's the amount that you invest. This on our timeline is now, and this is the future. Okay. And that is the simple interest. The second one we got was compound interest. Compound interest is the main one that we're going to use, and it is A is equal to P 1 plus I all to the power of n. And similarly, we draw it like this on what we call a timeline, now and the future. And we say this is A and this is P again. And in essence, this actually climbs like that, because it's an exponential equation. Well, what do we do inside the little blocks? I always recommend to the students to put them in the blocks. It's really not material. It's just a way of putting all my information together. We put the I here as a percentage per annum. And when we apply in the formula, I is the decimal. So we put our interest to a decimal. Do you remember previously we looked at the type of compounding? Compounded, Now I'm going to do the type. And I'm going to say, right, apply. And then I'm going to look at I. So the type was annual. Annually. Okay, I need two L's there. Thinking. Annually. You apply interest once per annum. So if it's compounded annually, it means I get interest at the end of the year and nothing in between. That's pretty much like simple interest. What if I do it semi-annually? Semi-annually, as it says, twice per annum. Then we have quarterly. Quarterly is 4 times per annum. Now, okay, let's do monthly. Take this up a bit. Let's do monthly. Monthly is 12 times per annum, and daily, which we don't do, is 365 times per annum. How do we now do the interest rate though? What do we say for the interest rate? Or let me rephrase it. What is the interest rate going to look like? Well, obviously here I is equal to the rate percentage over 100. Let us say they tell us I is equal to 10%. Therefore, I in this case is going to be equal to 0.1. Okay. What about this one? I here is going to be the rate in percentage over 100 times 2. Twice per annum, we have to do it twice. So my rate over here is going to be 0. Or rather, let me do it fully so that we've got it as the formula says. The rate over here is going to be 10% divided by 100 and times a half. So if I go and take that, it's going to be 10 divided by 100 equals that, divided by 2 equals 1 over 20, which is 0.05. So here it's 4 times. So I is going to be the rate percentage divided by 100 times 4, which is going to be 10 over 100 times 4. You can get the guess. 10 divided by 100 equals that, divided by 4 is equal to 0.025. Right? This is going to be equal to the rate percentage over 100, to change it to a decimal, multiplied by 12. So it's 10 divided by 100 equals that, divided by 12 is going to be, and my decimal is 8.33. It's 10 over 100 times 12, which is 8.33 times 10 to the minus 3. Straightforward. And the last one, yep, it's the rate in percentage divided by 100 times 365. 10 over 100 times 365. It's a small number. I'm not going to bother with it. And we're not going to use it in this scenario anyway. So essentially what we're doing is, if you like, we are working out what the rate is. But now, in all of these, please note that we have got N. The formula N. N is the number of compounding periods. So if we had, let's say we are looking at 1 year, we would have 1 plus, let me say, rate over 100. Okay. Now let us say we did a year, but we did it monthly. So it's going to be times 12. And up here, it's going to be 1 year times 12. That number is there. There's a very detailed explanation in the financial maths section in the previous year to have a look at that, where I've gone through it in quite a bit of detail. I don't want to get involved in this now because it's going to be, it's going to unfortunately take up a lot of time. It's something that we dealt with extensively previously. But suffice to say that we always have to make sure these numbers agree. Because if I change my rate to quarterly, it's going to be the rate percentage divided by 100 to change, and a 4. And then on the outside, it's going to be 1 times 4. That and that number must always agree. Moving along, we're now going to look at, we've looked at that. Now, let's do a few examples to recap. Very quickly, I did a couple of examples here. Let's just go through it to say here, let's say A is equal to 100. All right. Now, I'm keeping out of it a particular currency, but please remember, wherever you're watching this, you would use your currency, whether it's yen, euro, US dollar, Canadian dollar, Australian dollar, ZAR, whatever it's going to be. You would use your own currency, and you have to put it in. You will also, when we're using currencies, you go to the second decimal place, because we do have our currencies in decimals. So that would round it to the second place in the decimal. So let's have a look. A is 100, and I've put I equal to 10%. Look, let us find P, compound interest, 5 years. Now let us find P using compound interest over, let me just say over here, compound interest over 5 years. So therefore I'm going to say then I've got annually, semi-annual, quarterly, and monthly and daily. So what am I going to say? I'm going to say that P is equal to A times 1 plus I to the power of n. Therefore, over here, P is going to be 1,000. 1 plus I is 10%, which is 0.1, 10 over 100. There's my decimal, divided by 1, 1 times 5. And I end up with a number, and we can work that out. Let me do it. I didn't work that one out. So it's going to be 1 plus, okay. 1 plus 0.1 equals that, all up to the power of 5 equals that, times 1,000, 1,610.51. Right, you can call that dollars, you can call it pounds, whatever you wish. Now, let's have a look at semi-annually. P is going to be still 1,000. 1 plus 0.1 over 2, and it's 2 times 5 now. This gives us a value. I'm going to put my value here, 1610.51. Next one, 1638.62. Next one, quarterly, is 1,000. 1 plus 0.1 over 4. 4 times 5. 1638.62. 1638.62. The next one, P is going to be equal to 1,000. 1 plus, it's monthly, 0.1 over 12, and is 60 periods. You're going to get interest 60 times, which is going to be 1645.31. And then, lastly, ever so tar, daily is going to be P is equal to 1,001 plus 0.1 over 365, and it's going to be 365 times 5. My final answer is 1648.61. So we'd obviously all choose to have compounded daily. That is not, generally speaking, how the bank's obviously going to work these out. The next step is now I want to look at depreciation. What do we mean by that? For those of you who don't do accountancy, it means the loss in value of an asset due to usage. And essentially, if you buy a motor vehicle and you drive it for 5 years, you're not going to get back what you paid for it, unless it's some obviously sought after collector's vehicle. But generally, we're not in the league of buying those. So depreciation, okay, is going to call it, some people call it also decay. Okay, there's a reason for decay. Exponential decay occurs in some other areas that are mathematically aligned, but we'll get to those at a later date, not currently. Currently, we're going to just deal with the money. Now, once again, you get simple. And this is called straight line method. This is basically the financial policy, and it's going to be this here. A is equal to P 1 minus I to the power of n. That's the straight line. And using compound, this is called the reducing balance method. And here we say A is equal to P 1 minus I. Look what I did. Silly me. My bad. Minus Ni. I to the n. The simple is the ni, right? The simple is the ni. And when that decides to give me my pen back, like that. I, out of habit, always use compound interest. So you'll find if I'm doing simple, I sometimes have to do it twice. Now, what are we saying? If we look at a graph of this, fundamentally, this is now, this is time. And a straight line does that. That's straight line. The reducing balance does that. Comes down like so. So the one is exponential, the other is a straight line. This one is your straight line. You can see it if you multiplied it out, which we're not going to do because I'm pretty sure you guys have done that plenty of times. So let's say an example, just very quickly. Okay. If we have a car valued at 100,000, whatever it is, and it depreciates at 8% per annum, which is very low. On a reducing balance, okay, when is it worth 50,000? When is it worth 50,000 of whatever? Can you see it's actually worth half? So if they do say if it's worth half or worth a quarter, just pick a number, 10 or whatever you want, and just divide it and look at it that way. You don't have to do anything fancy with it. You can just do it that way. So therefore I can say A is equal to P, 1 minus I all to the n. And now if I draw it, what have I got? I have got this situation, haven't I? We've got 100, and there it's going to be. And what do I want to say? And they want us to know when. So n is our unknown. The interest rate is 8% per annum. And I'm going to leave it as annual. Okay, you don't have to you can change it to months if you like, but it's really no big deal. I'm just going to leave it as annual. Therefore, let me just move the page down. You can see the little drawing there. Now, therefore, I can say A is going to be 50,000 is equal to 100,000. 1 minus 8 over 100, right? And it's to the n. So here I've got, this is a half the value. 1 minus 0.08 all to the n, which is a half is equal to, that is 0.92 to the n. Now, how do we find n? Exponential equations. In this case, you take logs of both sides. Log of a half is equal to the log of 0.92 to the n. This you exchange to n times the log of 0.92. Therefore, number is equal to log of 0.5 over the log of 0.92. I always put them in brackets, I don't know why. Please note that in some textbooks you will see it as log to the base 0.92 of 0.5. That is the same thing. Because if you have a weirdo base like this, you would always change the base. We generally don't work with logs to the base 0.92 or anything else for that matter. You would change that to log to the base 10 of 0.5, log to the base 10 of 0.92, which is that. Why? Because we don't write the 10 in there. That's the change of base formula on logarithms. That is what we use, and my answer comes out to be 8.31 years. $8.31 years is in fact that for it to halve its value. We'll get this eventually to go up, won't we? Now, let's introduce a new terminology. Let's just take this out the way. Let us look at the word present. This is not rocket science. Present value and future value. Okay. Also called PV and FV. We are going to use it as P and F. Okay. Forgive me if I put PV or FV, but in a lot of financial textbooks, some of those behind me, you'll see they use PV. You also get things called NPV, net present value calculations, etc. Now, in this element, the present value is now. The future value is then. And in this, you have to look at the wording of the question. They are not going to tell you using this formula or using that formula. I'm also not going to show you the derivations of the formulas. I'm just going to use them as they are straight out of the textbooks. Okay. Now I want to also use a term called an annuity. What is an annuity? Is we make an equal generally monthly payment called installment. Let me just take that installment. Okay, an equal monthly payment installment. Okay, and everything else is the same. So instead of having a big lump sum now, P or A or P or A, instead of that, we're now going to split it into monthly payments. So what do we do? In other words, we say, right, we're now going to have a whole series of monthly, and monthly is where we're going to focus. A series of monthly payments that we're going to make. So you can already see that we would use the future value for a savings plan. The future value would be a savings plan. Why? Because we are saving for the future. Okay? College funds. A lot of people have got those. Retirement funds. People have got those. Maybe you're saving for a holiday, or you're saving for a whatever. That would be a future value issue. The current present value stuff generally would be a loan. Generally would be a loan. Loan to buy house, car, or some other asset. Could also be a business loan, right? So when we're looking at loans and things, we're taking it now. This is the now. We're taking a loan now. The future is something that we are looking at. Let us do a little bit of work on this, okay? Right, mostly done monthly. And we generally find that we have a formula called F is equal to X, and use the square brackets, not in the eraser form, and it's going to be 1 plus I all to the power of n minus 1. All divided by I. Now remember, mostly done monthly. X over here, X is the installment. Monthly, generally, but it could also be quarterly. I have done an example using quarterlies. Remember that once again, if we are talking about if we're talking about an interest rate quarterly and a monthly repayment, you have to change your interest rate to be an effective rate. The nominal rate, we have to change that to be an effective rate. I'm going to do one of those. So all of these basically, the last thing I want to introduce before we end this off is the concept of a sinking fund, right? The sinking fund basically is used by a business to save for financing, ongoing purchases. So usually for replacement of machinery, etc. And all it is it's this, and I'm going to get to the notation in the next one. It is how much, if I'm going to save, I'm going to be putting away every month to save up for a specified amount in the future. That is my sinking fund amount. That pretty much brings us, we're going to do some examples now. What I'd like to do is leave it at that point, and then let's just carry on. We've got a whole pile of examples to do. So I'll see you straight after, and we can carry on with the examples. That's gonna gel in our minds all of the concepts. We're going to do a few different ways of looking at these annuities. Thanks for watching. I'll see you in the next one. Ciao.